Hi guys, today for Chem 2 we're just going to go over the rate law and a problem that you might encounter in your class. So we're just going to work through the worksheet that's being put out for this week. So the problem is, one of the world's largest carbon sinks is the ocean, and when carbon dioxide interacts with water it can be converted to carbonic acid, which is soluble in water. So basically you measure the initial rate of this reaction several times and obtain the following data, which is presented in the table. When they're asking you to determine the rate law for the reaction of converting carbon to carbonic acid. So the way you want to approach this problem is to immediately go straight to the data table and determine what order the reaction is for both of your reactants, which is carbon dioxide and water. So the way you do this is by simply determining how the concentration of each of your reactants changes between whenever the initial rate changes. So if we label these 1, 2, and 3, we're going to go through step by step and see how the concentration changes. So for 1, or from going from 1 to 2, carbon dioxide concentration doesn't change at all, but the concentration of water does. So if you do 0.3 divided by 0.6, you see that the concentration, or sorry, the other way around, should be 0.6, that's the new concentration, divided by 0.3 equals 2, so the concentration of water doubled. And then you can also see that the reaction rate doubled as well. So sorry, not double. It quadrupled. So obviously the relationship between these two, every time water doubles, your initial rate quadruples. So that's going to lead you to think that the concentration of water should be second order. So we're going to go through the next two steps, going from 2 to 3, to confirm this. So here, carbon dioxide doubles. The water stays the same, and the initial rate stays the same. So if you're doubling your concentration of carbon, but the rate is staying the same, that means that the reaction rate is not dependent on the concentration of carbon. So that means that concentration of carbon is simply 0 order. So the next thing that you want to do is plug this into your rate equation. So you know that carbon dioxide is 0 order, water is double order, second order, sorry. So you want to plug this into the rate equation, which is rate equals constant K times the concentration of your reactants. And since we just figured out that this is 0 order, and this is second order, what we can do next is simplify this so we get rate equals K times the concentration of water squared. And then we just use any of the data points that we want from the table to figure out what this constant K is. So we're going to go ahead and use the first data point. So we're going to set 0.0057 the rate equal to K times the concentration of our water, which is 0.3, and square that. Then we'll divide over, so we'll get that K equals 0.0057 over 0.3 squared, and that equals 0.063 inverse molar seconds. So that's it for going through one of those problems. Hopefully that makes sense. And just a quick update, my office hours have changed from Monday, Wednesday, Friday in the morning to being just Monday, Wednesday, 9 to 10 and 3 to 4.